Okay, boys and girls, so today we are going to be continuing with fractions. We already multiplied fractions, we already added and subtracted fractions, so the only thing that is left to do for us is to divide fractions. So that's what we're going to be doing today. The objective we're going to be working on is 5.3J, representing divisions of unit fractions by whole numbers and division of whole numbers by unit fractions, such as 1/3 divided by 7 and 7 divided by 1/3 using objects and pictorial models, including area models. So today we're going to be talking about division of fractions. Specifically, we're going to be dividing whole numbers by unit fractions. And we're going to be talking about the different ways you can approach these problems, because you can use math to solve them, which would be considered standard algorithm. You can also use pictures to solve, because sometimes seeing it can help you better visualize and better find the answer. So that would be considered a pictorial model. Or you can also use number lines, and that would be considered a number line model. So let's go ahead and get started with our notes. Go ahead and title your notes, Dividing Whole Numbers by Unit Fractions. Now, before we get started with actually the solving part, there's a couple of words we need to talk about, our vocabulary words, that are very important so we can fully understand what we're talking about and what we're discussing. The first word we're going to talk about is unit fraction, because that's what we're going to be dividing by. That's going to be part of the numbers that we're going to be working with. And you need to fully understand what it is. Unit fraction. A unit fraction is a fraction that has a 1 as the numerator. Very easy. For example, 1/2 is considered a unit fraction because it has a 1 on the numerator. 1/7. 1/7 is also considered a unit fraction because it has a 1 on the numerator. And we can go on and on. 1/100 is also a unit fraction because it has a 1 on the numerator. 1/50, so on and so forth. If it has a 1 in the numerator, it's considered a unit fraction. Another word you're going to be hearing as we are going through standard algorithm is the word reciprocal. Reciprocal means to flip. For example, if I have the fraction 1/2, the reciprocal, when we flip it, would be 2 wholes, because the denominator becomes the numerator and the numerator becomes the denominator. You flip it. You turn it upside down. Another example would be, let's just do 1/5, and the reciprocal of 1/5, the 5 goes up, the 1 comes down, 5 wholes. Again, reciprocal just means to flip a fraction. Another word we're going to be encountering a lot is the word inverse. And inverse means opposite. For example, what's the opposite of white? Black. What's the opposite of girl? Boy. What's the opposite of dog? Cat. What's the opposite of division? Multiplication. So that's what inverse means, and that's how we're going to be using it. So let's go ahead and now get started with our notes, now that we know the words we're going to be working with. The first type of division problem that we're going to be working with is standard algorithm. Now, standard algorithm is what we like to use the most because it has numbers, and for us it's very easy and we can always do it because we're very used to using numbers. So let's go ahead and title this section Standard Algorithm. And again, standard algorithm is just a fancy word for just plain math, solving using math. And let me go ahead and give you a problem. We're dividing whole numbers by unit fractions. So a whole number would be, for example, the number 4. The 4 is a whole number. And again, we're going to be dividing. So then I would use a division operation symbol. And we're dividing by unit fraction. So let me go ahead and choose a unit fraction. And I'm going to choose 1/3. Whole number divided by a unit fraction. To solve this problem, there is a series of steps we need to follow. I'm going to skip a couple of lines because we do need a little bit of space. And then we can go ahead and get started with step number 1. Step number 1 is very easy. You know how to do it. It probably already comes naturally to you. You kind of don't even have to think about it anymore. But when you're working with problems that include fractions, it's important that all numbers must be fractions. So step number 1 is to convert that whole number into a fraction by putting an imaginary 1 underneath. And the step is to have all numbers be fractions. All numbers must be fractions. Put the 1 underneath the 4. And now this is a fraction. It's an improper fraction, but it's a type of fraction. And this is a proper fraction. Now that we've done that, we can go ahead and move on to step number 2. Step number 2 tells us that we're going to keep the first fraction. And I know this step probably doesn't make a lot of sense to you right now, but as we continue to solve, it'll make sense. So I'm going to put a K here for keep. I'm going to keep that one. I'm not going to do anything to that number. I'm just going to keep it. Now I can go ahead and move on to step number 3. Step number 3 is to do the inverse of the operation. And remember, inverse means to change it to the opposite. So this division right here needs to be changed. It needs to be changed to its opposite. What is the opposite of division? That's right, multiplication. Now we can move on to the next step. Step number 4. And step number 4 goes with the last number that we're working with. We're going to do the reciprocal. And remember that reciprocal means to flip. So I'm going to take this and I'm going to flip it. And let me do it over here because I have more space. Remember, you're going to keep the first one, 4 wholes. Division changes to multiplication, and I'm going to flip my second fraction. The 3 comes up, the 1 goes down. The numerator becomes a denominator, and the denominator becomes a numerator. Okay, and now this type of problem looks like something very familiar to you, something that we've been working for quite a while now. So now we can go ahead and move on to step number 5. Step number 5 is to solve using multiplication steps. So all those steps we talked about yesterday and a couple of weeks before that about multiplication, we're going to apply them now. So all I need to do is multiply numerator times numerator. 3 times 4 is 12. And denominator times denominator. 1 times 1 is 1. Making my answer 12 wholes. And from what you see there, you already know that 12 wholes is an improper fraction because the numerator is greater than the denominator, and we can't have that. That's part of the steps in solving multiplication problems. So what we need to do here is we need to convert that into a mixed number or a proper fraction. So we would usually divide, but because we have a 1 underneath, we can do like we did here, where we made it appear. Well, here we're going to do the opposite. We're going to make that 1 disappear, making my answer 12. Let's go ahead and do another example so that it can start making a little bit more sense to you. Let's do a whole number such as 7 divided by a unit fraction such as 1/5. 1/5 is a good example. All numbers must be fractions. That means that this 7 needs an imaginary 1 underneath. I'm going to keep my first one, change my second value there, and flip my fraction. Keep, change, flip. That's what you need to memorize. Keep, change, flip. Let me rewrite it because it's a little messy. Keep the first one. Division changes to multiplication, and I'm going to flip my second fraction. The 5 goes up, the 1 comes down. And now all I have to do is apply my multiplication steps. 7 times 5. If I look at my timetables, I know it's 35. And it can't get any easier than multiplying 1 times 1. 1 times 1 is 1. Now to get my final answer, I need to make this 1 disappear. It's going to become imaginary again. We don't need it anymore. And we are going to keep the top number, making my final answer 35. Let me go ahead and give you another one. Let's make it a little bit bigger. Let's do 12 wholes divided by 1/4. You're going to keep, change, flip. Keep the first fraction. Division changes to multiplication, and I'm going to flip my second one. The 4 goes up, the 1 comes down. And now all I have to do is apply my multiplication steps. 12 times 4, 48. And if you don't know, you can always look in your timetables. And then it doesn't get any easier than 1 times 1. 1. Now I can go ahead and eliminate that 1 because we're making it invisible again. And we're going to keep the whole number, 48. Now again, this is one way of solving. This is standard algorithm. This is my favorite, and it may be your favorite too. But there's other ways to solve these problems, and they may seem easier to you because they can be easier. And the next type of strategy that we're going to be learning to solve division problems is pictures. We're going to be using pictures. So let's go ahead and turn to the back of this page. And let's go ahead and title this new section because this time we're going to be using pictures to solve. And that is called pictorial models. Pictorial models are models with pictures. And so you can see that it doesn't matter if you use pictorial models, if you use standard algorithm, or if you use number line models, which is the next one we're going to be talking about. It doesn't matter which one you use. All of them will get you the right answer and the same answer. So I'm going to go back to the first problem we used, which was, and let me just look very quickly because I already forgot, 4 wholes divided by 3. 4 wholes divided by 1/3, I believe. Yep, 1/3. Okay, and a pictorial model is a picture, a visual, something that you can see why the answer is what it is. So to be able to draw this pictorial model, you need to look at the problem and understand what each thing in the problem represents. You need to understand what the whole number represents, what division represents, and what the fraction represents. So the whole number, the very first number, and not necessarily the whole number, but the very first number in a division problem tells us what we have. I went to the store, I bought 4 chocolate bars. So that's what I have. I have 4 whole chocolate bars. So let me go ahead and draw that. 1 whole chocolate bar, 2 whole chocolate bars, 3 whole chocolate bars, and my last chocolate bar, 4 whole chocolate bars. Division, the symbol division and the operation division, when you divide something, what that means is that you're splitting it into equal pieces. You're cutting it into equal pieces. So this symbol right here represents to split, to cut, to break apart into equal pieces. So we're going to be splitting up what I have, my 4 wholes. I'm going to be cutting them up into equal pieces of 1/3. The 1/3, the fraction, tells you how many, or the sizes of the parts. So this one I need to cut it into thirds. So I need 2 little lines to make 3 spaces. So this is 1/3, this is also 1/3, and that's also 1/3. And I'm going to do the same to all of them. I need to split all of them up into 1/3 pieces. Split them up into 1/3 pieces, 1/3, 1/3. And then split this one up into 1/3 pieces. 1/3, 1/3, 1/3. Oh, I put an extra one in there. Good thing I have an erasable pen. Let me redo it. 2 lines make 3 spaces. 1/3, 1/3, 1/3. Now my answer is the total pieces. Because if I split my 4 chocolate bars into 1/3 pieces, I want to know how many pieces I have to share with my friends. So then I have 1 piece, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have 12 little pieces to share with my friends. And if you notice from the front page, 4 divided by 1/3 using standard algorithm, you have to do all of that work and it gives you the same answer, 12. This one requires a different type of work. It requires you drawing pictures. Some of you like to draw pictures more than you like to do numbers. And these are just 2 ways of solving it that will get you the right answer. So you can choose whichever one you like to use whenever you're solving these problems. Let me go ahead and give you another problem so we can practice one more. Let's do 3 wholes divided by 1/2. So I have 3 brownies because I love brownies. This is what I have. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have 12 little pieces to share with my friends. And if you notice from the front page, 4 divided by 1/3 using standard algorithm, you have to do all of that work and it gives you the same answer, 12. This one requires a different type of work. It requires you drawing pictures. Some of you like to draw pictures more than you like to do numbers. And these are just 2 ways of solving it that will get you the right answer. So you can choose whichever one you like to use whenever you're solving these problems. Let me go ahead and give you another problem so we can practice one more. Let's do 3 wholes divided by 1/2. whole brownie, 2 whole brownies, and 3 whole brownies. Division tells me that I'm going to split them into equal pieces. I'm going to split them in half. Half. 1/2. And this is also 1/2. I'm going to split this in half. 1/2. And this is also 1/2. And I'm going to split this one in half. 1/2. And this is also 1/2. How many total pieces do I have to share with my friends? 1, 2, 3, 4, 5, 6 pieces. The answer is 6. Total pieces. And lastly, there's another model, there's another type of strategy that you need to know to be able to solve division of whole numbers by unit fractions. Another way of solving it is using number lines. So let me go ahead and split it up here, because this is another example. This is number lines. Models. Number line models. And as you already are thinking about it, yes, number line models have to do with number lines. So let me go ahead and go back to my original problem. 4 wholes divided by 1/3. Now we're going to follow the same idea that we used on top, but instead of drawing a picture, this time we're going to draw a number line. So the 4 is what we have. I have 4 chocolate bars. So I'm going to create a number line. And I'm going to represent 4 holes in it. You always start with 0. 0 is always the first number in your number line. And this is 1 hole. And this is 2 holes, 3 holes, 4 holes. And what I have, my 4 holes are being split up into pieces that are all equal to 1/3. So it's being split up into thirds. So to split it up into thirds, I need 2 little lines. 2 little lines makes 3 spaces. 1, 2 makes 1, 2, 3 spots. Split it up into thirds, split it up into thirds, split it up into thirds. And my answer is the total pieces. And to count them, you just do little hops. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 little hops. The answer is 12. So as you can see, you can use number lines, you can use pictures, or you can use standard algorithm, and you would get the same answer. Some of you like to use numbers, some of you love to draw, and some of you love to draw number lines. Let me go ahead and give you another one so you can continue to understand how the pictorial model and the number line model work. So let me go ahead and give you the problem. Let's just do 5 divided by half. A whole number divided by a unit fraction. Remember, this is what I have. It's going to be split into 2 halves, or into halves. So let me go ahead and create my number line. And remember, number lines always start at 0. And this is my 1 hole, 2 holes, 3 holes, 4 holes, 5 holes. And I'm splitting them up in half. So this piece here, cut in half. That part there, cut in half. This part there, cut in half. And this part there, cut in half. And lastly, this part there, cut in half. And what I want to know is the total hops from one side to the other, the total little pieces. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 pieces. Don't have to do reciprocal, don't have to do inverse, don't have to use my multiplication facts. All I have to do is draw a little picture. So those are the 3 different ways of solving division of whole numbers by unit fractions. Okay, boys and girls, you can go ahead and pause the video now so that you can go ahead and take out your textbook. And on your textbook, I want you to turn to page 471. Again, on your textbook, I want you to turn to page 471. And if you choose, you can put away your notebook if you feel you kind of already know how to do this and you can probably work on it without looking at the notes. But if you still feel you need a little bit of help, you can go ahead and leave your notes out. So I'm going to leave mine right here close to where I can see what I wrote, just in case I'm still having a little bit of trouble. Go ahead and pause the video, take out your book. And now we're going to go ahead and work on this practice so we can better understand how to do it. And as we're going through the problems, we're going to be doing standard algorithm, we're going to be doing pictorial models, and we're going to be doing number line models. So those are the 3 different types of ways we're going to be solving this problem. You need to know all 3. And we're going to skip the top part. We're going to go ahead and start with number 7. Number 7 says 4 divided by 1/2. Now, if you're going to use standard algorithm, you're going to keep, change, flip. I'm going to put a 1 underneath my 4. I'm keeping my first fraction. I'm changing division to multiplication, and I'm flipping my second fraction. The 2 goes up, the 1 comes down. Now all I have to do is use my multiplication steps. 4 times 2 is 8. 1 times 1 is 1. The 1 becomes invisible, so my answer is 8. How would I do that using a picture? We're going to do that right over here. Okay, again, the problem was 4 divided by half. 4 divided by half. Okay, make sure you can see that. Okay, so remember, the 4 is what I have. I have 4 holes. 1, 2, 3, 4. And those four holes are being split into half pieces. So I'm just going to cut this in half. I'm going to cut this in half. Cut that one in half. Cut that one in half. And what I want to know is how many total pieces there are. 1, 2, 3, 4, 5, 6, 7, 8. There's 8 pieces. So 4 divided by half gives me 8 pieces. 8 total pieces. How to do it in a number line? Well, you're going to apply the same thinking as a pictorial model, only you're going to represent it a little differently. You're going to use a number line instead of a picture. Again, what I have is 4 holes. So I'm going to start with 0, 1, 2, 3, 4. And then I need to split them in half. Half, 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 half. How many total pieces? 1, 2, 3, 4, 5, 6, 7, 8. Same answer. Let's go ahead and move on to number 8, which is 2 divided by 1/8. And I'm going to write it here. I'm going to write it on my extra sheet of paper. 2 divided by 1/8. For standard algorithm, for math, basic math, I need to make sure all my numbers are fractions, and then I'm going to keep, change, flip. Keep the first one, change division to multiplication, and flip your second fraction. The 8 goes up, the 1 comes down. Now all I have to do is apply my multiplication steps. 2 times 8, 16, 1 times 1, 1. Can't get any easier than that. The 1 becomes invisible. My answer is 16. How many holes do I have? I have 2 holes. 1, 2. I'm cutting them into equal pieces of 8. 1, 2, 3, 4, 5, 6, 7 lines make 8 spaces. 1, 2, 3, 4, 5, 6, 7 lines make 8 spaces. So how many pieces do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 pieces. Same answer. The number line. Always start with 0. How many do I need? How much do I have? I have 2 holes. 1 hole, 2 holes. I'm splitting it up into equal parts of 8ths. I'm splitting it up into 8ths. 1, 2, 3, 4, 5, 6, 7 lines make 8 spaces. 1, 2, 3, 4, 5, 6, 7 lines make 8 spaces. 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 16 pieces to get to the hole that I need, which is 2. The answer is 16. Same answer. 3 ways of solving. Let's go ahead and do the next one.